To name a cycloalkane, you're also going to follow the same composition of most of the IUPAC names. That'll be prefix followed by parent name and then suffix. For simple cycloalkanes, you would name them as cyclopropane for a 3-member ring, cyclobutane for a 4-member ring, cyclopentane for a 5-member ring, and so on. For a complicated cycloalkane, you need to first find the parent hydrocarbon. There are two scenarios. The first scenario is if the number of carbon atoms in a ring is equal or greater than the number of carbons in the largest substituent chain, the compound is going to be named as cycloalkane, with the alkyl group as the substituent. And this is a typical example. For this example, you're going to name this compound as methyl cyclopentane. And the second scenario is if the number of carbon atoms in a ring is less than the number of carbons in the largest substituent chain, the compound is going to be named as an alkane, and your cycloalkane would be named as a substituent, just like in this case. In this case, you have 1, 2, 3, 4 carbons in the longest continuous chain, and you have only 3 carbons in the ring. For this case, this 3 carbon is going to be named as cyclopropyl substituent, and you have another substituent that'll be a methyl group. Therefore, to name this compound, you're going to name this compound as 2-cyclopropyl 3-methyl-butane. If you have more than one substituent, and you need to number your ring and make sure all of your substituents have the smallest possible number. That being said, and one of your substituent would be bound to carbon number 1. In this case, and you could start either from this carbon, number the cyclohexane ring to the left, or start from this carbon and number the cyclohexane ring to the right. And therefore, for the case of this molecule, you're going to number this carbon as carbon number 1, 2, and 3. Therefore, this molecule would have an IUPAC name as 1,3-dimethyl-cyclohexane. In the case of this example, there are 3 different substituents. To make sure all the substituents have the smallest possible number, you're going to start on the right-hand side. Therefore, you would have your substituent on carbon number 1, carbon number 2, and carbon number 4 to make sure all of your substituents have the smallest possible number. Moving on, if in the scenario that 2 or more different alkyl groups receive the same number, and the number, you would number your substituents with the alphabetic priority. For instance, in this case, you have an ethyl and a methyl group, and you're going to number the cyclobutane ring from the left-hand side. And therefore, this cyclobutane molecule would be named as 1-ethyl 2-methyl cyclobutane. And you could apply the rule for the rest of the molecule. When you have a ring system, and the substituents on the ring system may occupy either face of the ring. Under that circumstances, you will have to identify where the substituents are. For instance, this cyclopentane ring is drawn as a 5-member ring that's perpendicular to the plane of the screen. Therefore, you can clearly see that these two methyl groups both point down or on the same face of this cyclopentane ring. We could also draw a cyclopentane on the same plane as the screen. Under that circumstances, we would use dash to represent where the methyl is connected to, use the wedge to describe where the hydrogens are bonded to. Under these circumstances, both of the descriptions are correctly describing the same molecule. Okay, you're going to name this compound as cis-1,2-dimethyl cyclopentane. And for this case, this is probably what you are going to see more often, and hydrogens are not shown, but you know that since this ethyl group is pointing up with this wedge, and this methyl group is pointing down with this dash, so this ethyl and the methyl substituents are trans from each other. So you're going to name this compound as trans 1-ethyl 2-methyl cyclopropane.